Hello and welcome to another video. In today's episode we are going to be talking about Godot, and I will show you how I achieved the following for OpenSuspect. So this is something that we needed to do because you can see that basically our game has this top-down perspective with horizontal and vertical walls, and I want these horizontal walls to disappear. So you can see that the right hand side have not yet been done yet, only the left hand side, so focus on that. So you can see that we have all these walls around there, so when we go into this room we can see that there are all these things inside there. But when I go into this room I want to be able to move down to the edge of the wall, and to achieve that you can see that now part of our wall have been removed, so I can go in here and I can see what's going on, and I can also see my other character when I enter this other room. And so this problem had to be solved using two things, and I will go into more detail what are those two things. But first let's just take a look how this disappearing wall works in OpenSuspect. Alright, so here we are in our Godot project. This is our test map. You can see it contains this bottom part, which is just very basic things. And so this is the top part, is what we are working on currently to implement like a nice hand-drawn map instead of these ugly bulk walls that we have here. And as you can see, we have a lot of things in a left-hand window there. Let's take a look at these things. And so, of course, we have all these walls, but these walls are actually those ugly ones. And what we have in this, the main room, top room, left room, right room, and offices. So we have offices left and offices right, and as you can see, this is the left-hand side have been properly implemented, the right-hand side have not. And so let's just open this offices left. And you can see here that this file, this scene in our project is containing these three specific rooms. And let me just collapse these on here on the left hand side. So can I just I hope you can read these font sizes. Maybe I can try to adjust them. Let me see. Okay, so I managed to increase the font size here. So now you can see that this basically all three rooms have their separate Y-sort nodes. So these are Y-sort nodes because I want the things that are inside it to be sorted by their Y coordinates. So our character should be able to move behind the the table and the chairs, or the table right here, and also the walls should behave the same. So that's why we use the Y-sort nodes. You can see that, let's say, take a look at the kitchen, which is the middle room here. It contains like this one sprite, which is basically like the background for the kitchen. We have the table and the chair added here, like sprites and static bodies. Maybe this is not like the most ideal setup here, but anyways, what is important is like we have, let me just make them disappear, all of them, and let's bring them back one by one so you can see which one is which. So in the kitchen we have the equipment, which is just collision boxes for all the things there. We have the right wall, which contains the collision boxes and light occluders. Left wall is similarly chair, table, and so this is the kitchen background, and we have the kitchen bottom wall, and this is kind of the important thing here. So this kitchen bottom wall is similarly our pantry, which is this room down here, also has this pantry bottom wall, and similarly the meeting room on the top also has the meeting room bottom wall, which is this wall. And you can see that when I turn this off, a lot of color disappears because this scene is quite complicated. So let's just look at like the most simple one. This is the pantry. The pantry wall will be kind of the most basic one of these. So let's open that scene. And so once we are in this scene, we can see here on the left hand side that these things are gray, so I hope you can see that these are grayed out and not like white, like our main node. This is because this is based on like a universal type of scene. So I have one scene that will be used to make all these specific ones, but it contains all the general things, the general properties and general mechanisms by which I hide these walls. And for that, I just have to open this horizontal wall .tscn. So this horizontal wall, you can see it contains, it's basically blank, so it doesn't really contain anything specific. It just contains these nodes like a sprite, because of course our wall have to be shown to the players, and for that we need to have a sprite that will contain the texture. We need a light occluder. Light occluder it works to restrict the vision of our player, and player collision, this is basically the area to which our player is not allowed to enter. And this area detection is going to be basically if our player enters this detector area, then our walls will be removed. So for example here, how is it implemented? The sprite is basically just this simple wall graphic, or if we can take a look at some other, like maybe if we take a look at the kitchen bottom wall here, you can see then it's much more complicated because of the shape. But if I remove everything here, you can see that the sprite, this is basically the sprite of the wall there. And we are not going to save this, of course. So let's just go back to our pantry here. So this is a sprite. We have a light occluder. So light occluder is this shape. And why this is implemented this way? Because this will mold together with this other wall. So we have the left and the right hand side walls, and the left hand side walls and the right hand side walls both have these light occluders, I hope. Let me just make it disappear. So you can see that these light occluders on the two sides are only to this point. But if I add my pantry here, my pantry, like the bottom wall, contains this light occluder here. But what I want to do is move this light occluder to the bottom whenever someone enters the pantry. But in that case, we would have like these empty places in the sides which does not occlude the vision. So our player could in theory just go down here and see outside this room, which we don't want to happen. So that's why this is how our light occluder looks like. We have the player collision. That's very simple. It's just the bottom of this wall. So we want our player to be able to move up, down until this point. So that's the collision. And you can see that the area detection is not added or not modified here. But if we move to this, and let me just turn off everything else so it won't disturb us. And the kitchen bottom wall, why is it still visible there? Oh, because it's part of our pantry for some reason. Yeah, this is part of the pantry sprite for some reason. Anyways, what we need to take a look here is this pantry bottom wall. So the, where is it? The editable children has to be turned on. So once the editable children is turned on, we can simply just change the properties. So we can use this detector area here and add like a type of a polygon, and this is in red because that have been changed compared to like the original scene that we are using. So the original scene does not have this detector area, but this we modify this node here, and we add this basically this collision polygon with these four sides. And so this this collision polygon does not this is not like a player collision, so it will still allow our player to enter the room, so it won't collide to the side of the room. This is used as a detector to to check whenever someone enters the room, and that is connected through this area detection node's signals. So this area detection is an area 2D, and you can see we have the body entered and the body exited triggers here. These are signals. So whenever someone enters, so the player enters, and we can see in the inspector that, where is this collision? We are masking for the second layer, which is the player's layer. So whenever a player is entering this detector area, so this orange colored area that we are talking about, then these signals here will be triggered. And let's just move to the script to take a look at that thing. So here we can take a look at our code, which is, so this is the code for our pantry bottom wall. And so this extends the static body 2D because, well, this is like, okay, so this script is actually, you can see here, this is from the horizontal wall GD. So actually this is this, what is this called? So this scene's script, but this horizontal wall is just used in all the other scenes which are built on this. So the important things here that we have this fade speed, which will define how fast our bottom walls will disappear. We have the fading in and fading out booleans that will tell us whether we are currently in the process of making the walls disappear or making the walls appear back. And we have the occluder height and the occluder top, and we have the occluder bottom variables. So you can see that these three are not totally independent of each other. The occluder bottom is an exported variable, which means that when I go back to my pantry bottom here and make it disappear, we can see that we have the occluder bottom variable in the script variables here. And if I open like a different one, which is a more complicated one, like my pantry, no, this is my pantry bottom wall. So like the kitchen bottom wall, the kitchen bottom wall has a different number at this occluder bottom, and we will get into it why. And just go back to the script here. And so in the beginning, we just make the occluder top. It's basically just gets the coordinate of the light occluder from our drawing here. So we don't have to enter that manually. We'll just get this light occluders. Where is this light occluder? So it will be the coordinate of this light occluder. So you can see this crosshair here. If you look really carefully, this is our position. So this aligns with this top line of the bottom wall, this position. And if we go back to the script here, then the occluder height will be calculated as the difference from the occluder top and the occluder bottom. This is just for the easier readability of the code. Let's just jump this process function and let's just go here. So whatever is going to happen, these are the two functions that are connected to the signal. So whenever someone enters, or rather the main player enters this room, or whether this main player is exiting the room, both cases we will just call this check fade function. But in this case, if the player have entered, then this will be called as a true value here, this entered boolean, and if the person is exiting, then it will be this false. This entered variable will be false. And what it does is just checks, okay, are we sure that this body that have entered this area, is it a player? Is it really a player? And is this the main player? So we don't want some other person's character moving into the room and disappearing the wall on our screens. We only want the wall to be disappearing on our screens whenever our own player's character moves in there. And so if the entered is true, so we have entered the room, then fading in will be turned to false and fading out will be turned to true. And so if we are leaving the room, then fading in will be turned to true and fading out will be turned to false. So this is basically just switches these two booleans to whatever it needs to switch to, and then this process function will basically just run every time. So this is the process function which runs like every time the frame that is being shown by Godot is processed. And if we have this fading in variable turned to true, that it means that we need to fade in our wall sprite, which is it's just going to use this the modulate property, the modulate property of this wall sprite. So wall sprite is just our sprite here, and the light occluder is the light occluder. So these are the variables that contain those nodes. So our wall sprite will be modulated with its A value, alpha value, which is the transparency. So the transparency will be increased if we are fading in. Well, it's not transparency, it's opacity. Sorry, it's the opposite of transparency. So the opacity will be increased by this delta times the fade speed. So this delta is how much time have been spent since the last time we processed the screen, or the what is it called, like the screen buffer, the displaying of the things, and we multiply that with the fade speed. So this will make the wall sprite more and more solid. So when we are fading in, so that means that the wall has already been totally disappeared. So it will be 0, its alpha value, and then we leave the room and the fading in kicks in. So it's just getting more and more solid. That's what this line does. And then the light occluder position Y will be also increased. And that will I guess raise the light occluder, and it will also use the occluder height. So we want this, the occluder is very high, so from the bottom to the top there's a big difference, then we want, of course, it to move faster, and if this difference is very small, then we want it to move slower. So that's what it does. And if we have reached the point where this alpha value, the opacity, is higher than 1.0, so it's like totally visible, then we just switch the light occluder to the top position and then turn off the fading in. If fading out is true, the opposite is going to happen, so we are making the sprite more transparent and we are moving the light occluder in the downwards direction. And if we reach 0 for the alpha value, then we just put the position of the light occluder to be the bottom and stop fading out. So I guess this is all in this script, but to understand exactly, I will just go back here. So in this case, we want our light occluder to be, let me just turn this back on, sorry. So I want my light, when I enter the room, I want this light occluder to move down to the bottom. So this is our current position of the light occluder, this X you can see here. Let me just, instead just go, like you can see it's minus 49.4. So this is the current position, and I want this just to move down to 0 whenever, someone enters the room. And then let me just undo this change. And you can see, like, this is where the original position, minus 49.4. And so this is how this light occluder will move to the bottom and will then move to the top. And in this sprite case, it will be just modulated to disappear. And so now that we discussed all this, let's just go back to the game and let's take a look and analyze the workings based on our knowledge of the code. Alright, so you can see that we are here next to the wall, and you have to take a look at this wall here, and then I entered this room. You can see that this part is just disappearing. So what happens here is that the sprite that contains this whole wall that disappears, and just there is another sprite in the bottom that is exactly up to this point. And the same thing in the left corner here. You can see that disappears, and also like here, this is the top where my vision enters. So this is like how far the light from my head is entered. So there is like a masking light on our player which emits a ray, and this ray will, you know, like collide to the light occluder. So this one is outside of our vision, this is inside the vision, and then the light occluder here will just stop our vision right there. But then I move in and the light occluder moved down. So you can see here how like the light is slowly moving down, slowly moving up, and the same thing happens here, but with a different height. So in this case, because this wall is more simple, I can afford to remove like a bigger part of it, and you can see that this, how much I remove is exactly matching with this size of this faucet here, because I don't want to break the sprite where the faucet is, because you can see that currently there is some discrepancy with our sprites, not perfect. We will probably like modify these sprites in a way that so it won't be like noticeable. So we will make like a pattern that will contain some kind of the horizontal line. So when this kind of discrepancies appear, it won't be that bad. And so like you can see here, there is some kind of a problem with how this is implemented, because now I just realized that there is no light occluder here that would once our walls moved up. And so here I need to zoom out a little to see how this works. So you can see that now these light occluders don't match up perfectly. So there is some kind of the extra visibility inside this wall, but this won't affect the gameplay, but it doesn't look nice. So this is something that, you know, once we are more close to like effectively releasing a playable game, these kind of things will have to be created. You can see the same thing, like this wall does not get disappeared much more because just it's very complicated. Probably we just have to take into account when designing rooms. So now I still cannot hide. So if there is another character behind this wall and I'm entering the room, it's, you know, it's impossible to hide behind these walls. Which would be, of course, it would make no sense, because this player is inside this room, this other player would be also inside this room, so it makes sense to watch, to be able to see them. It wouldn't make sense just because from my top-down view, I cannot see it, just to not see it. Okay, so, and I told you this is just, this is the major issue we solved here, so this is kind of the important part, but there is something I told you in the beginning of the video, that this is in itself is not kind of like a perfect solution, and I am going to show you what is the problem and how we have to solve that additional issue in the next segment. Okay, so because I've already solved this problem, I can only show you from like an old screenshot what was going on, but basically what I did is, once this wall, you can see that this is what you see in the bottom here when you are below the wall, and when you move like on the other side of the wall, and if like this wall is disappeared, like in this case I just removed the whole wall for these testing purposes, you can see that because now this character's position is around like just below the wall, so you can see the head shown like above the wall, because our light occluder is only at this point. But even if I did not remove this whole wall and try to like cover the head, I would still see like the name of the player above its head. So I could just basically practically see through the wall. So I needed to solve this, and for that I used a very interesting method, which I will show you. So for that we need to take a look at the player scene, and in the player scene, what you could see in the screenshots, that time we only used the main light and the masking light for showing and hiding things, and so these can be put on the head. So you can see these crosshairs here on the head of our player, and what it does is basically it illuminates the map around the player, so we can see, due to this main light, what is the edge of our vision and what is behind the edge of our vision is made darker, and what's inside this light source and what's in our vision is made brighter. While the masking light will do is basically anything that's outside our vision range will made invisible. So this includes the other players, and also includes like items that are on the floor. So once they are outside of my vision range, they won't be visible to the player. But that was not enough, because you can see that the light is on my head, but it is possible that the other player is like somewhere around here. But even though there is like a wall between us, it's the other player's head will be like in a position that I can still see it due to these light sources. So what I wanted to do is to add an obstruction finder to the leg. So if there is any obstruction between the leg that would matter, like a wall, for example, then we can use this obstruction finder to see that, okay, so between these two players' legs, there is an obstruction. So technically these two players should not be able to see each other if they were like moving in like a real three-dimensional space. And for that we use the Raycast 2D node, which you can see it's enabled. It excludes parents, so it won't see its own, like the parent is the player node here, so it won't just start, okay, there is between me and the other player, there is me. I don't want that, so it's turned off. And we use this collision mask. So this is bit 6 of the collision mask, which we use to determine if there is anything. So if there is something that's not on this 6 bit, or this not on this 6 mask bit, that still doesn't matter. So if there is like a chair between us, that doesn't matter because it's not on this bit. We only want to hide the other player if there is a relevant vision obstructing element between us, and that's what this collision mask is doing here. Alright, so now that's clear, we move to the script. And so for the scripts we have the player script, which has this hide player and show player functions, and basically like there is also the physics process function, which is similar to the process function that we discussed in the horizontal wall case. And what it does is basically similarly to our horizontal wall, it just checks, should I be fade in, should I be fade out, and it uses only this modulate property of our player, so it hides or makes it solid depending on whether it's fading in or fading out. And we have the hide player and show player functions that can control it. So once the hide player is called, we'll only do it if the player is visible, because the player if is not visible, then why bother? And if the player is, if the players, like the modulation is less than 1.0, then it means that it's either in the process of fading or it is disappeared. So it will just show the player by turning the visibility true, and then fade in true and fade out false. And so you can see here visibility is also turned off once we modulated our player to 0, just to make sure that it doesn't appear. But how do we call this show player and hide player? So until this point we don't know how to use this Raycast node there. So that is actually used in the players.gd script, and this script is actually attached to a main scene. The main scene takes care of like loading the map and changing the map, switching from map to lobby. It also takes care of the items. It takes care of the players on the map. And so the part which takes care of the players is in this players.gd script. And for that, we run this process function. This is also same kind of process function that we previously talked about. And what it will do is it will check the global position of the main player. So the player of me, so I play the game and my character is having this ID, and whenever like this ID appears in this player's, this player's, it's a dictionary, and so it contains all the player sprites. like the reference to each player sprite, so we can just see, okay, I need my own player's coordinates, like the global position on the map, and I put it in this to variable, and then I just go through all the players in this dictionary except for myself, and I will get this other player's obstruction finder node, and once I just assign this obstruction finder node to this variable, I will cast the ray from the obstruction finder node of this other player to my own player's global coordinates, which is basically where my leg is located, and just force a Raycast update so we can check whether there's something between these 2 points, there's something that this ray have intercepted just right after this point. So we will get the player finder colliders. So whatever this will result in giving us the first thing that this ray have collided with, and that will be put in this result variable. And if this result variable is empty, that will mean that there is nothing between my player and the other player on this collision mask. And if there is something in this result variable, that would mean that there is something between the two players. So if there is nothing between the two players, I will just call the show player, and if there is anything between these two players, then I am calling the hide player script. And these will just simply take care of showing the player and hiding the player when it's behind this kind of walls, and that will make sure that that doesn't happen that I just showed you in this screenshot over there. So this situation won't happen because you can see that there is this wall here, and that wall is between our feet, so that will make the other player disappear. And for this to work, of course, what you have to do is, as you can see in our horizontal wall here, the horizontal wall is put on this physics body 2D collision, and this sixth bit, which is the region obstruction. So of course it has the terrain layer, so it will tell us that the players will collide into this horizontal wall, and the region will be obstructed. This is what it tells us. And so, of course, this is added to the physics body 2D, but actually the shape of this collision will be, of course, determined by the collision shape child of this static body 2D node. And this is how in this office space, every one of these bottom walls, if we go here, you can see pantry bottom wall and kitchen bottom wall, and also meeting bottom wall is on this. And I've already also put actually these other walls on that sometimes. Collision, where are you? No, not this one. But for example, this left. No, not this one either, I guess. So oh, I didn't do this. Well, okay. I thought I did that. Yeah, some of them I did. Kitchen I did, for example. But it's, you have to make it up for yourself. What is your use case? Because this kind of thing, what we've seen on the screenshot right here, this only happens at the horizontal walls, because basically the player sprite is never wider than the collision itself. So you can see that this is our collision shape, and this collision shape is like wide enough so the player in this horizontal direction will never really go through the walls that the vertical walls that it bumps into. But of course our collision is much shorter than our player sprite, which means that we have to deal with this in the case of the horizontal walls. So this is dependent on the use case. Sometimes I did, sometimes I didn't do it consistently, because these walls don't have that layer turned on. Okay, so this is the end of the video. We discussed everything that is relevant for us to achieve this kind of vision obstruction and the disappearing walls and things like that. So hope you can use this information when you are making your own project, because let's face it, this kind of 2D style games, which is kind of top view but also a little bit side view, so might have this kind of issues. This kind of game style is popular nowadays, so maybe you can use this information to be implemented in your own game too. And if you want more Godot tutorials, there will be definitely coming out later. But, whenever I solve some issue in the game that I find it interesting enough to talk about, I will make a video about it. Give this video a like if you enjoyed it and if you find it useful. Leave a comment if you have any kind of question or comment down below, and subscribe to this channel for more content, because here we are dealing with Godot and other free software projects and free software operating systems like Arch Linux and stuff like that. So if you're interested and don't want to miss the updates, then subscribe to the channel or follow me on Mastodon, which, probably you can find in the description or somewhere. And I will see you next time. Bye bye.